Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 637. Average of levels in binary tree. Given the root of a binary tree, return the average value of the node on each level in the form of an array. Answer within 10 power minus 5 of the actual answer will be accepted. Okay, this is not needed. So just see here, return the average values of node in each level. So we want to return the average values of each level. So it is what? Level traversal, that's it. So we want to do a level traversal and take the average of the each levels. Okay. So take for example, this is our array. Sorry, this is our tree. Now, at first level, what is my value? It is 3 alone, right? So 3 divided by 1 is equal to what? 3. So this means first value. Yes. Then take this. 9 plus 20 is equal to what? 29. 29 divided by 2 is equal to 19. 19 or 14, right? 14.5. Okay. Now, 15 plus 7 by 2 is equal to what? 15 plus 7 is what? 22, right? 22 divided by 2 is equal to 11. So this should be the output. Can you understand this? This should be the output. So this is what the question says. Now, how can we do this? Just see here. Take for example, we are now going to do a level order traversal. Level order traversal. Okay. How to do this level order traversal? First, initially take a queue. Take a queue. Okay. Now, put this root inside the queue. Okay. Put this root inside the queue. Okay. Fine. Now, anything else in this level? No, right? So initially, we will put this in the queue. Now, take this 3 outside. Take this 3 outside. What is the length of this queue? It is only 1. So I can say at the first level, it's only what? A length of 1. So I will take this 3, then divided by 1. Is equal to what? It's equal to 3 only. Okay, I got the first level answer. Okay, now it's time to take the next level. So what are the 3's left and right? 3's left is 9. 3's right is 20. So put inside this. Anything else? That is anything else? No, right? So stop here. So while putting in this, we will take the running sum. So initially when I put 9, my running sum will be 9. Then when I put 20, my running sum will become what? 29. Okay. Now what is the length? The length is what? 2. So 29 divided by 2 is equal to what? 14.5. Fine. Now again, take this 9 outside. Take this 9 outside. Now, what is the left and right of this 9? That is nothing. That is nothing. Okay, just leave it. Take this 20 outside. What is our left and right? I can say my left is 15. So put. My right is 7. So put that also. Fine. Now again, I will make my sum as 0 initially. Now see here. First I will pop this 15 out. So I increment my sum as 15. Sum as 15. Now, what is the left and right of 15? There is nothing, right? Okay. Now, I will pop this 7 outside and increment in my standing sum. So, it will become 22. And I put any left and right? No, there is no more left and right. Okay. What is the initial length? It is 2, right? So, 22 divided by 2 is equal to 11. So, I got 3, 14.5 and 11 as our answer. Now, I should stop here because my queue was what? Empty now. My queue was empty now. When my queue was empty, I should stop my BFS traversal, right? Or level order traversal. Okay. Now, it is fine. We found by using what? Queue. What if they are asking us to find using what? BFS traversal. What if they are asking us to find using a DFS traversal? Okay. Let me redraw the tree. 3, 9, 20, 15, 7. 9, 20, 15, 7. Okay. Now, what is the main thing we want while using a level traversal? We want the levels, right? We want the levels. Okay. What is this level? I can say this level is my first level. This level is my second level. This level is my third level. Okay. So this level plus 1 is this. This level plus 1 is this, right? So my core concept is that I want to keep track on each and every elements and its level, and I have to make sure that I will store those levels in a separate, maybe a hash map or maybe a array list or vector like that. Okay, let me show you. First, what's the next level? It is 1. Okay, I'll take an individual hash map. Now, the first level's element is what? 3, right? 3. Okay. So I just put 1 and I just use a list and store 3. 3 in it. Okay. Now, you may use a pre-order, post-order, in-order, anything. Anything. We are doing a separate condition, right? So you can do anything. I chose a pre-order traversal. Okay. Now, I go to this 9. Now, this 9 is at where? Second level. How can we say it? So it is first level. So it will be 1 plus. So it will be 1 plus 1 which is equal to what? 2. So it is at second level. So put 2 and put 9. Yes. Now again, it will backtrack. Then it comes back to this 20. Now, 3's levels is 1. So plus 1 which is equal to what? 2. So this 20's level is 2. So I put this 20 at the second level. Yes. Now again, go to this 15. This 20's level is 2 plus 1. So this 15's level is what? 3. So the third level has 15 recently. Now it backtracks, then comes to 7, and 7 will be updated in my third level itself. So this is my dictionary. Yes. Now, just tell me, we want to take the sum and the average, right? We want to take the sum and the average. So how can I take the sum and the average? Just see here. I take this one, the first level. Okay, 3. What is the sum? It is 3. Divided by, what is the length? It is 1. So I can say which is equal to 3 alone. Yes. Okay. I take the second level, which is what? 9 and 20, right? And I'll put 9 plus 20 divided by 2, which is equal to 14.5. And then I will take 15 plus 7 divided by 2, which is equal to 11. So I got every answer, right? I will take each and every level from this dictionary only. Okay. You can do like this, or you may keep track on the sum and also the count also. Like, see here, see this carefully. I'll take a separate dictionary. Okay. Now, at first level, I will put 3 and the count is 1. Like this. At second level, I will put like this 9 is counted at first. So, I will put 9, 1. Then when I count this 20, I will put 29, 2. Like this. And understand, this means the sum is 29 and the count is what? 2. And then for 3, I will put the sum is something like 22 and the count is 2. So I will do each and every time what? This sum divided by this count. This sum divided by this count. Sum divided by this count. That's it. We got answer, right? So we can do either of these two methods. Okay. Now, what is the time complexity and space complexity? I can say my time complexity and space complexity for this solution might be lie between n into log n, because we are using what? We are traversing entire 3 nodes, and also I use a dictionary, right? I use a dictionary inside which we are just get and putting the some values, right? So instead of this dictionary, if I use anything like array list, see here, this can be implemented by using array list, right? So if I use array list, this log n complexity will be gone. Understand, right? So what is the space complexity? It is something like O of this will takes a height. This recursion will takes a height plus this dictionary also take the height. So approximately it is what? O of x. Okay. Now for this first approach also the time complexity is same as this. Okay. Now let us see this 2 code here. Now let us see the code. See here, the first thing is by using a queue data structure. So see here, I taking a result, then def BFS of root. It is not necessary to use this also. If you want, you may use this function, right? Inside this function. Let me take this. We don't want this function unnecessary. We can also do like this. Now it is easy, right? Right. Now, see here. I just take an empty queue. Now, if not root, then how can I traverse? So I will just return. Now, queue dot append of root. So I'm just putting a root inside my queue. Okay, this is insert step. And while queue, L is equal to 0. Initially the sum is equal to 0. And L is equal to length of queue. And I'm iterating to the length of that queue. And I'm popping that queue's front value. I'm taking the front value. And if that node has left, then I should include that left in my queue. And if that has right, I should include my right in my queue. Can you understand this? And then S is equal to S plus node dot val, which means I'm taking the node's value and storing in the sum. I'm adding it, right? And then after completing this entire loop, I can say I have that entire sum of that level. We can have that entire sum of that level. So I will just divide sum. I just take a sum divided by the length. Okay, inside my result, and I return the result. Let me submit it. Yes, it is submitted successfully. Now let us see the next approach. The next approach is that a DFS approach, inside which we will store each and every elements. Okay. Now see here, def DFS of root, comma level. Now if not root, then return. Else we want to traverse in that tree. Okay. Now first we want to traverse in root.left and increment my level by 1. And then I want to traverse inside in my right subtree and increase my level by 1 in each time. Can you understand this? I'm doing a simple post-order traversal. If you don't know about a traversal, it is so. This question don't understand for you. If you don't know about the traversal, this question, this solution might not be familiar for you. Okay, just go back and watch my traversal video and come back. Okay? It is in the playlist. Okay, now if level is not in D, then what should I do? D of level is initialized with empty list. Now D of level dot append of root dot val. Can you understand this? I'm just adding each and every level's value inside my dictionary. Now, I'm calling that root by using what? Root, comma, 0. You may use as 0 or 1, anything. But at the end, what is the level? Level, the first level plus 1, then plus 1, plus 1. You can use. Okay, now, the result is equal to empty list. Now, I is equal to 0. So, my first level is what? 0. I just use 0 here. If I use 1 here, I should give here also a 1. Here also a 1. Can you understand this? Okay. Why I in D, what should I do? I should take that sum divided by that length inside my result and append it. Okay. And to I plus equal to 1. And I should return it. Let me submit it. Yes, it is submitted successfully. Now it's time to see the last approach. See here, it is same like that, but still what I have done here is inside a level. A level is a key in the dictionary, right? In the dictionary, I take two values in a list. Those two values are, one represent the sum, one represent the length. Okay. See here, I insert 0, 0 when it is the level not exists in the dictionary. And I do like in the 0th index, I do addition of the roots value, which means I'm taking the summation of the every roots at that level. And at the first index, I take the count of how many nodes present in that particular level. Okay. And then I call the DFS function. Okay. Now I take a result. Then I take I is equal to 1. Then while I is in D, what should I do? Result dot append of D of I of 0 divided by D of I of 1. Can you understand this? I'm just dividing count or that sum and taking into my result and adding my I 1 by 1. Then I'm returning that result. Let me submit it. Yes, it is submitted successfully. Thank you.
We have